Mechanism nitration of benzene, so it must be involved the reaction between aromatic ring arene reacted with the concentrated nitric acid, the presence of catalyst sulfuric acid concentrated in condition 50 to 55 degrees Celsius, and the process involved should be substitution one atom hydrogen with the group of atom nitronium, which is NO2, and the side product is H2O. So now we need to prove how NO2 can be substituted with hydrogen by using the concept of electrophilic aromatic substitution reaction based on to the three steps. So the first step, remaining formation of nitrogen ion, which is our electrophile species. Okay, we are target the formation of nitronium ion. And then second part, similar mechanism before, rhenium ion. And finalize the formation of final product by loss of proton. Okay, so the first step mechanism, it must be involve the formation of the nitronium ion. So it must be reacted between concentrated H and O3. So we rearrange the atom inside the molecule H, O, and the group of nitronium NO2. And at the same time, you must be sure the lone pair at the oxygen atom, and it's reacted with the sulfuric acid, and we rearrange the atom inside the H2SO4 HOSO3H atom. So the step mechanism involved between the two reagent given, our target here NO2. So what happened? The first lone pair at oxygen in nitric acid will form covalently bond with the hydrogen in the sulfuric acid molecule. So at the same time, the bond between H and O will break. So the two electrons together will give directly toward to the oxygen atom in the sulfuric acid molecule. So the product intermediate can be formed as here, which is H that already have bonding with oxygen, and it have one lone pair, so it can form a new bonding pair with one hydrogen atom, and the rest NO2. And what happened to another side product OSO3H, and this oxygen have a 3 lone pair, and when we calculate the formal charge, this oxygen is negative charge, and we conclude the ion of this molecule is negative charge. So while the charge of this oxygen here, 6 valence electron minus 5 electronic charge around itself, and it will become positively charged of the oxygen atom. And this reaction further, which is this oxygen require electrons. So at the same time, this bonding pair consists of 2 electrons sharing together. So the 2 electron here will give directly towards the oxygen because oxygen require electron. So the new product formed from this molecule of ion here, we can get HO, which is the formation of the water molecule plus NO2. So this NO2 nitrogen become charged positive. So either this ion, you can draw the specific structure as a N double bond with O, and then this also double bond with O, and this oxygen have a 2 lone pair together, and we calculate the formal charge nitrogen 5 valence electron minus 4 electron itself, so it will become positively charged. So we can conclude this is our target nitronium ion in stage 2. So, in a step 2, it must be involved between the aromatic ring with the nitronium ion, and covalently bond must occur between carbon and nitrogen. So, one of the bonding pair here will form bonding towards to the N plus ion, and the product can be formed as a rhenium structure. So, we can form aromatic ring, and we just have another 2 of a double bond, but this place we refer to the addition of NO2. But at the same time, so this we have the remaining hydrogen atom. So what happens? So neighboring carbon will become carbo, okay? cation. So this stage we can call as a structure rhenium, and it will delocalize of the electron inside the ring, which is the resonance structure occur. So how the resonance structure occur? The first position of the multi-bond here will change the position, means double bond will alternate to the here. So the two electron will stabilize between two carbon atom, and the intermediate product can be formed arrow reversible, arrow full headed both side, and product intermediate as a new structure of aluminium. The new position double, and positive charge must be lompat satu. So maksudnya daripada position here, so positif dia akan dapat dekat sini. So and then this is remaining double yang kita tak guna lagi, and we have NO2, and it's continuously. So second position double bond alternate position at this area, and the new resonance form as a double bond at here, positive charge di sini. This is NO2. So this is remaining double. So we bracket them because they are charged. So all of them you are labeled as a rhenium ion. And the final steps, you must be choose the first structure of the rhenium. So the first structure of the rhenium, target kita nak dapatkan our final product. So remember, this process is a electrophilic substitution reaction. So what happened? We already added NO2, so we must be replaced of the hydrogen by reacted with our first intermediate product, which is O, SO3H, to ensure sulfuric acid to form again. So prove they are catalysts. And the mechanism involved must be from one of the lone pair here attack hydrogen, mean it can form covalently bond with hydrogen, and at the same time this bonding pair will stabilize their own carbon and neighboring carbon to form a multiple bond, which is a double bond form occur. So product we form, the remaining double bond of a structure arene and NO2 presents at here, and the side product is HOSO3H, or you can write also H2SO4 as a catalyst. So we can conclude the final product we can already have by using this step mechanism.